So to me, cloud native is the new way to build applications for production. We call it new because there are new technologies like containers, Docker and Runc and all that good stuff. But also there are new techniques. And the one that I go to every time I talk about this is the declarative API. That's a really powerful idea because you don't write any more scripts to deploy to cloud native systems. You do write YAML.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean's developer cloud makes it simple to launch in the cloud and scale up as you grow. They have an intuitive control panel, predictable pricing, team accounts, worldwide availability with a 99.99 uptime SLA, and 24/7, 365 world-class support to back that up. DigitalOcean makes it easy to deploy, scale, store, secure, and monitor your cloud environments. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Changelog Plus is now a thing. Support Go Time and all Changelog podcasts with your membership. Ditch the ads, get closer to the metal, and help ensure we produce awesome Go Time episodes into the future. Join now at changelog.com/++. Okay, let's get right into it. Cloud native. What? Here we go.
Hello and welcome to Go Time. Today we're talking about cloud native, whatever that means. We're going to find out. Joining us today, Johnny Borsico. Hello, Johnny.
Hello there.
How are you doing?
Feeling a little cloudy.
That's good. That's good today.
I like it.
Yeah. We're also joined by John Calhoun. Hello, John.
Hey, Matt.
How's it going?
It's going well.
Great. This conversation intro is it's really good. Let's see if I can lift the spirits with the
I'm just ready to get past this and get to the cloud native part.
I know you're so excited.
I, like you, don't know what we're talking about today.
Yeah, John doesn't know what it is either. Well, I've got a very special guest today as well. We're also joined, believe it or not, by Aaron Schlesinger. Yes! Hello, Aaron.
Hello.
Welcome back.
Thank you. You know, I think you get better every time with the last name there.
Ah, yes. Thank you.
He's so excited too when he gets it right.
Yeah.
I introduced him at a conference once and spent a lot of time learning how to do it, and I became the fastest Schlesinger swinger in the West.
Yeah, that was the talk, actually. It was just you learning.
Just learning his name.
He's like going over like all the background of it and like how they started pronouncing it this way.
I'm actually really interested in that.
Live chat with his grandma.
The etymology of Aaron's name. Yeah, cool.
Well, speaking of etymology, cloud native. I genuinely don't really know what this means. Now, I looked on the CNCF website on GitHub, actually, and they have a nice description for it, and they have it in lots of languages. So which one should I read? I could do the German one, maybe, or maybe the Korean one could be cool. Maybe Jap. Do you know what? I think I'm going to take a stab at the English. Cloud-native technologies empower organizations to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid clouds, containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. Okay, does that help us?
Was that like the UK English version? Is there like a US English version? It's probably dumbed down a little bit.
Yeah, it's like
Yeah, dumb it down.
Is there a 5-year-old version? What does this mean?
Yeah, explain like I'm 5.
I need that. But what do we mean then by cloud native?
I'll take a stab at it.
Stab it.
Please stab it to death.
I'll only do it in 4 paragraphs instead of the 5 that you got there.
Okay.
So to me, cloud native is the new way, maybe the trendy way, but I'll just leave it at the new way to build applications for production. And we call it new because there are new technologies like containers, Docker and runc and all that good stuff. But also there are new techniques. And the one that I go to every time I talk about this is the declarative API that you mentioned, Matt, in that description. And that's a really powerful idea because you don't write any more scripts to deploy to cloud native systems. You do write YAML. And the rest of this podcast is now going to be
About YAML.
yeah.
In YAML, I thought you were going to say. Now we have to speak in YAML, including somehow pronouncing the white space.
Yeah. Tab.
Yeah.
Yeah, so you describe what you want to happen instead of how it should happen, essentially.
So, if I may, so I think Aaron, you're jumping into sort of the implementation details a little bit. Let me add some preceding layers, right? Speaking of layers, let's try to define cloud native as sort of a layer cake, if you will, right? So your first layer, right, is first of all, let me go before that, right? So back in the old days, I'm making air quotes here, you used to have your monolithic applications that run somewhere in a data center, right? With your rack of 1U servers and you have a disaster recovery. Maybe you have multiple data centers and all these things, and you're managing all this sort of infrastructure, right? You have a team dedicated to swapping out hardware and all these things, right? And then we were like, okay, so the cloud, right? The providers like AWS and now we have GCP and Azure, like these things exist, right? So we don't have to have our own data centers. Why are we spending so much money managing our own hardware? So we're like, okay, let's take advantage of infrastructure as a service, right? And then what started to happen is that, okay, now that we have people sort of taking care of the hardware and the virtualization and all this stuff that we don't have to take care of ourselves anymore, we started thinking, well, how can we then make developers more productive, right? How do we we got the infrastructure part, relatively taken care of. How do we make developers productive? Because in the world of monolithic applications, so it is said, things are take longer to change. You don't have as much flexibility in all these things, and people are kind of stepping over each other. Release processes are long, and all these kind of things that folks sort of attribute to monolithic applications. Which some of it has merit, some of it is just incorrect. But that we get to that. And then now we're like, okay, well, let's build ourselves a layer here, right, of abstractions, so we can actually allow developers to be more productive. So you take the cloud infrastructure, the infrastructure as a service component, you add on top of that, right, a nice sort of smattering of scheduling and orchestration, right? This is where your ECS, your EKS, your Kubernetes, your OpenShift, all these things, this is where they live, right? And then now you're like, okay, now we need some services, some application and data services layered on top of that, right? And then so now we put a nice smattering on top of that. This is where your databases live, your storage layer. This is where you basically have a sort of a provider supported, building blocks, application building blocks. Hey, you don't want to run your own sort of a Redis, caching server. We'll run that for you, right? Or hey, you can use DynamoDB. You don't have to run your own database. We'll run that for you. These kinds of things, right? And now we're like, okay, how do we even abstract things even more? And then now we have application runtimes. We used to call these things middleware back in the day, right? But that layer, now we start to standardize things like logging and events and tracing, because with cloud native comes the whole shift to break up your monolith and have, instead of one big ball of mud, you've got now 500 balls of mud, smaller balls of mud, right? And they all need to talk to each other. They all need to, you kind of need to observe the system. You kind of need to know what each piece is doing when when a customer makes a request, it hits one front end, and then that talks to a dozen other back ends. And if something happens, you don't know where to look, right? So you need instrumentation, you need observability, you need these things to be, connected to each other. This is where you got the service meshes and all these sort of new fancy things, the Istios and things like that. That's the layer where they live, right? And then you get to your application code. And this is what we're basically trying to get to all along, right? The nirvana developer productivity, where the only thing you need to do is write your code, package it up in a container, right, and then ship it. And then this is where your Dockers and rockets and things live. This is where your serverless, right, even another layer of abstraction on top of that, right? So we're just trying to get to the point where we can actually ship software faster, right? So that's the layer cake. Visualize it. And it's complicated.
Wow. I could listen to that for hours.
While Johnny's explaining how this is the modern way to do it, I'm like looking over at an old Linux box sitting on my shelf, like running a server that I use for stuff. And I'm like, yep, that's not modern, but okay.
What's running on there, John?
It's like some backup file storage and some other stuff like that I sometimes want to access, like if we're off traveling and my wife wants to get some photos off of it, that sort of stuff.
Oh, right. Yeah, that's cool though that that we have these ideas, and they obviously have come out of people solving the same problems again and again, and then once you've done that a few times, and actually sometimes before that, as developers, you sort of see these patterns, these common things that we could then build abstractions on. And it is very useful, like from a developer's point of view, of course, because, and this is how I actually use this technology personally. I write applications and I let then the something else, the cloud, do all the heavy lifting of making things work and making things, scale. In our project, if we get a sudden spike of traffic, then more instances are automatically spun up to deal with that, and they'll spin down as well after, so when they're not being used. So things like that then become possible because we have these abstractions. But what does it mean for application developers then? Do we do things differently now that our code is going to run in this different way? It's running in this abstract environment versus on John's computer in a corner of his office.
John, you need more reliability, man. My apps keep crashing. You need some redundancy.
I mean, luckily, these are things that don't need really, really high reliability. Like, my reliability is a backup battery plugged into the wall in case the power goes out.
Ooh,
That's pretty much it.
Yeah.
That is fancy. I don't have that.
Yeah, same here.
Yeah.
I wanted to add something to what you said, Johnny. There was a part of that cake in there that made a transition from what I think of as the traditional ops role. I don't really know if it's DevOps or ops, but that kind of role. And it made the transition into the developer role, the developer realm. And I think that's a really important one because we have a different transition now than before we had cloud native stuff. Before we were talking about IaaS, VMs and VNets and all of that stuff. But now we have things like Kubernetes that abstract over a bunch of compute resources and network resources and storage and all that stuff. So now, whether you look at Nomad or Kubernetes or ECS or even App Engine, Heroku, that kind of stuff, now there's an API to abstract over your entire cloud or your entire subscription to the cloud or whatever you've got, even over your entire physical data center as well. And so that is really interesting to me now because we kind of have an operating system here that describes your entire system, whether it's 1,000 VMs or 2 VMs or John's Linux box, whatever it is. And John, if you had it, like, of course, you could add more Linux boxes and the system would work the same. I think that's a really powerful abstraction that lets us pretty easily standardize on that transition from traditional ops to the development experience you were talking about, Johnny. And your experience too, Matt, because we've got now this API at the OS layer, and now we've got standardization on that, so we can move up the chain and get to things like serverless. And I know you use App Engine, Matt, so you get to stuff like that, and maybe beyond. I think we'll have to see.
So can I ask you two a question, Johnny and Aaron? What problems were you first facing when this type of solution really looked like it was going to like save you a lot of headache? Like, do you remember like when you first started looking at it, what problems you thought it would solve? Or I guess like, did you have something in mind?
So before I answer, when you start talking to folks about what does cloud native mean, inevitably the conversation drifts into, well, you need to sort of decouple components. You need to transition from your monolith to microservices and nano services and serverless and all these things, that are supposed to work with each other and all that stuff. There's an inevitable sort of push towards sort of breaking apart, right? The reason, right, and very seldomly are you told why you need to do that, right? Which is why there's such a backlash around microservices and all these things. Like, it's trendy to have microservices, 2 pizza teams or whatever. I mean, all this stuff, but there's a reason why you break up, a monolith, right? One of the reasons being to be able to independently scale one piece, right, that is receiving that has higher demand on it than another piece, right? Because without that, right, you're forced to now scale your one application vertically, right? You need to beef up the server, add more RAM, more disks, more CPU power. You need to keep that's called vertical scaling, right? You need a bigger server to run your one thing, right? Whereby if you have smaller components, well, if this component only requires 2 logical CPUs and another one requires 8 logical CPUs, then you can kind of these things don't have to live in the same box, right? You can sort of distribute that, right? You could scale these things independently and horizontally, right? So that is one of the great benefits of having this breakup, right, into small components. So that was my first sort of a true realization of what I guess even before cloud native. I think the term cloud native, if I'm remembering correctly, came either around the same time as cloud native or before it. I can't remember exactly, but I think the idea, the promise of microservices and cloud native, in connection to that is having that flexibility. It's all about flexibility, because at the end of the day, we're doing this not because it's cool to break things apart into smaller pieces. We're all engineers, and supposedly we all like Lego pieces to play around with and sort of assemble things together. I mean, that's all well and fun and all that, but at the end of the day, we work for businesses, and businesses have the goal of making money. And one of the ways they make money is by being innovative and being agile. And I'm really using the lowercase word agile here to be explicit. So the innovation comes in terms of speed, get to market first or go to market quickly to respond to market demand and that kind of thing. When you have smaller pieces that you can orchestrate, right, and sort of put, the horsepower where you need it kind of thing, that all these things feed into the innovation. And having developers who can work on different pieces of the platform, it's not all one big thing, and you have to worry about deploying that one big thing. You have release managers whose entire job is to just move things around, just prep things for release. Like, you can have that flexibility, right, of teams being able to ship things independently, right, and still have some sort of interconnectivity within these things, right? That's the flexibility. That's really why we have cloud native applications, not because it's cool to break out of a monolith into microservices, not because it's cool to run infrastructure.
Okay, so making sure I got that right, and I know this paraphrasing is going to be butchering it, but it sounds like a huge part of it was that your organization needed to be more efficient, and part of the ways you could do that was by breaking things up into smaller pieces that could be independently deployed, worked on, everything like that.
Mm-hmm.
Okay, so like I asked that not because I think cloud native is a bad thing, because like I worked at Google before I went off and did my own stuff, and while it wasn't Kubernetes and Docker, they had essentially their own internal version of, getting resources for all this stuff. And, Google wasn't just spinning up a monolith. I think we all pretty much know that wasn't what was happening. They don't make computers that beefy that I'm aware of. So, it was just one of those things where I'm trying to figure out from other perspectives what problems you were solving as you dove into them. Because from my perspective, I haven't seen an obvious need for these things. And I think part of it's just because of the things I'm working on. But I also want to know, like, are there problems that I'm not paying attention to? Or are there certain things I'm not paying attention to that these might be able to help me with?
The last job I had, we were building a platform as a service, and it was always containers. So we started on CoreOS with their Fleet system. I think that's deprecated now. So it was sort of, we will take a container and we'll put it on X number of machines. And that was what Fleet did. And that was pretty powerful at the time because you had the sort of beginnings of that abstraction of, I don't need to care about VMs anymore. I can give an API a container name and it'll do its thing. And once we got to that point, we then had to start breaking things apart because a platform as a service has lots of different logical components that don't necessarily fit together. And this is right along the lines of what you said, Johnny. It has a Git SSH server. It's got a logging component. It's got an administrative interface and a control plane, and the list goes on. So once we hit that point where we said, we just can't have a monolith with all of that stuff in it at once, because managing that thing, opening all the different ports and managing certificates and all that, that's just not feasible for us. So once we got all of our stuff running on Fleet, we then had to reinvent the wheel and figure out how to do secrets and distributed locking and all that stuff. And then Kubernetes came out, and then we just adopted all the primitives that Kubernetes gave you. But stripping away the Kubernetes part, even though that was great, and stripping away Fleet as well, the idea, we could have implemented it ourselves, would have been painful, but we probably could have. I'm not going to say definitely, probably could have, is the fact that, yes, like we had a technical requirement that stuff was split up, while at the same time, stuff could interact with the other stuff. The service A could interact with services B and C in a way that was manageable and that didn't require two different operations and release management teams to manage services A, B, and C. And that's what, for me, that was right at that moment. I remember this. Right at that moment, I was dreading having to build those systems to manage all the things and route network traffic and all that stuff. And once we found Fleet, that was when we went down this road of starting to think about an abstraction and starting to think about independently scaling and starting to think about how to organize the team around all these different services and manage the sort of organizational aspect of this. Starting to think about a lot more things too, but right then and there was the seed that got planted in my mind that started me down this whole cloud native road.
What's up, Gophers? Are you looking for a way to instantly debug and troubleshoot your applications and services running in production on Kubernetes? That's a mouthful. Well, Pixie gives you a magical API to get instant debug data. And the best part is this doesn't involve changing code. There are no manual UIs, and all this lives inside Kubernetes. Pixie is an API which lives inside your platform, harvests all of your data that you need, and exposes a bunch of interfaces that you can ping to get data you need. Pixie is essentially like a decentralized Splunk. It's a programmable edge intelligence platform which captures metrics, traces, logs, and events without any code changes. And the team behind Pixie is working hard to bring it to market for broad use by the end of 2020, but I'm here to tell you how you can get your hands on the beta today. Links are in the show notes, so check them out so you can click through to the beta and their Slack community. Once again, links are in the show notes, check them out, and look forward to Pixie Day coming soon.
So, when you're building something simple and little, would you recommend that people still build it in this way? Or should you start with a monolith and then, when you need to break it out later, do it then? How would you approach that? What would your advice be?
I'm going to use my unpopular opinion card right now.
There you go.
Yeah, absolutely not. That's like if you're one or two people, write all the code in one repo and deploy it all as one thing. Because the overhead of taking your 2-person team and trying to manage all of the different microservices and getting them to talk together and play well together, that's going to outweigh, that effort's going to outweigh the actual code you write. Let me share one more metric there.
Go on. No, please.
I've worked on and seen apps that have more Kubernetes YAML than they do code. So that metric is disturbing.
That's a sign right there. You're doing it wrong.
Yeah.
That's when you ask, is this a project for school? Because otherwise it's a little scary.
Yeah, for sure.
Yeah, so I was thinking then, so it's not that you can just use Kubernetes and everything's easy. There are still challenges that come with deploying in this way. It is still a big trade-off, right?
Yeah, absolutely.
Yeah.
Here's to follow up with Aaron's statement here. I totally agree. You should definitely not jump into microservices and all these things and doing orchestration and all that stuff, especially if you don't have the staff for it. It's a different competency. You require a different kind of mindset, right? Yes, you can be a developer and be sort of operations minded. I mean, I can define myself as that, right? I'm a software engineer who happens to do operations, right? So the thing to sort of keep in mind is that if all you need is to ship an app and have it run, and if you stick with the monolith, right, use a PaaS, right? Use Heroku, right? Because they're taking care of all that for you. I guess I'm unconsciously biased here because I work at Heroku or something like it, right? To run these apps, and so that you don't have to worry about it. Again, remember why we're leaning towards cloud native or want to take advantage of cloud native applications. Keep the ultimate goal in mind. It is for productivity. It is for developer productivity. Your job is not to run operations. That is not where the business makes money, right? Unless your business is to build a Heroku or a PaaS, right? You have no business really, trying to run your own Kubernetes or something like that, right? I mean, to me, that's kind of, not, and I'm going to get some heat for this, but that's kind of nonsensical, right? You're not building a platform as a service for other people to run stuff, right? Maybe you're an enterprise, you have lots of different departments that have lots of different, a lot of business software and things like that. And maybe, having your own sort of orchestration tooling, all these things to allow different teams to deploy things is the right approach. But you have to get to a certain scale or a certain level, right, before you can reach that. If you just want to launch an app, just run the darn thing on a PaaS, right? One of the mistakes I see developers make all the time is they get lured by all the announcements coming out from reInvent and from Google's conference or Azure's conference. They see all these nice shiny bells and whistles, things are like, listen, AWS released about 2,000 products last year. That's an average of 6 a day. I mean, that's ridiculous, right? So all these things are just lures, right? And let me see if I can integrate some ML services into my app here. But before I can do that, I need to set up the AWS account. I need to run things on EKS or ECS. I can't just deploy this thing, like on an EC2 instance. I got to break it up. I got to have microservice. I had to have a container. Now I need a CI/CD pipeline. Oh, I need to break this thing into, different storage components. And I got to use DynamoDB. I got to use S3. Now, you bring in all these things so that you can actually take advantage, right, and do things the way, right, it is prescribed, the way it is being marketed to you as a developer, right? So again, like it's tempting. It is very tempting because we're engineers. We see new and shiny. We're like, ooh, I want to use that. Or you're thinking maybe, hey, like, and I think we've all seen resume-driven development here too, right? It's like, hey, I want to use that tech, right? Let me find a reason, right? Let me convince my boss that we need tech so-and-so, right? Now you're bringing in that complexity into your world, and now you have to orchestrate around it. It's basically like a self-fulfilling prophecy almost, right? So you're bringing all these things in now, and rather than having one problem, which is ship this app and then get paid for it, now you have 2 problems. Ship this app, and all the small pieces that go along with it, now I have to manage and orchestrate and all these things and then still trying to make money.
So why is Kubernetes so popular then if most people shouldn't really be paying any attention to it, for example?
I think a lot of people have really good use cases for Kubernetes.
So are they running it themselves or are they building platforms as a service? Or platform as a services? I don't know how to pluralize that.
Is it like deer, where you just say deer?
I don't know. Just say deer. How are people building deer?
You just like say pass, and since it's an acronym, like
Right.
they can put the S or whatever ending they need on there.
Brilliant. Thank you. Yeah, I've solved it.
So I think it depends. The amount of pass, I think, increases as the organization size increases. Because they have, once you get to, your 30, your 40, your 50 person engineering groups, now you have to really draw those lines between, oh, hey, here's the DevOps team. Oh, hey, here's the ops team if we have that. Oh, hey, here's release management. Hey, here's development. And those roles, that's a Venn diagram. That's not separate, mutually exclusive groups. So now you're going to have people on Kubernetes who are touching it as YAML developers. And you're going to have other people writing Flask apps who don't care about YAML. They want to get their app up, and they need a public IP, and they need an SSL certificate and whatever else. So those are really, really different personas. And at that point, now you're looking at a group of probably SREs who are going to be writing code to make it really, really easy for developers to deploy that Flask app, but also make it really hard for them to mess up the Kubernetes install and make it really hard for them to do something that's going to, I don't know, deploy an API that doesn't have an SSL cert, for example, or something that's bad practice, pretty much.
So I didn't realize there were YAML developers now.
Yeah. Oh, yeah.
Yep,
It's a
that's
thing.
us.
That's us, yeah. For better or worse.
Right.
They didn't ask you to start YAML time yet?
It's YAML time.
Today's the day. This is it now.
Here's another thing I'll add to that here, is that I think sometimes teams are also lured by the perceived discipline that running something like a Kubernetes, right, brings, right? And by that, I mean sort of the microservices approach, right, to sort of tie these things together. The microservices approach requires basically you have a network boundary between these things, right? So now, these components have to have clearly defined APIs to talk to each other, right, which kind of forces some discipline, right? Hey, team X, you promised that you'd have these endpoints, for this thing, or you promised you'd implement this RPC service for that thing, whatever it is, right? So it creates some nice sort of compartmentalization, right? And some discipline, right? You have different managers managing different teams, different timelines, different deliverables, all these things. So it's like it bubbles all the way up, right? So that discipline, right? I think that we're sort of seeking, sort of inherently seeking as part of adopting these orchestration tools, right? I think that it's that lure is dangerous, because if you were an undisciplined team before orchestration tooling, you're still going to be an undisciplined team after orchestration tooling. Right. That the tool is not going to make your team more disciplined. You can have discipline around a monolith. You can have discipline around established processes for delivering software, which has nothing to do with the actual tooling itself. Tools are enablers. Basically, if you're relying on tools to help you establish discipline, that's like saying, okay, I'm going to buy a piece of software and I'm going to shape my business to fit into how this software is coded. Now you're following somebody else's business processes, however they've chosen to encode that, right? And businesses, I'm pretty sure, right, your business is probably not seeing things the way you are, right? So again, try to be disciplined about your practice, the engineering practice, the software delivery practice that you have internally before you attempt to bring in new tools into your world, because that's just going to add to your chaos.
That is a really interesting thing, because I kind of felt like, yes, if you have a framework, and I know some companies essentially do this, they have a prescribed way, including like command line tools that will generate the stubs for services and things. So in a way, and because everything else is automatic, you do get a lot for free. And like you say, you can't make those kinds of mistakes. But it does seem a little bit too good to be true. So that is very interesting to hear that you still have to build good software, which is kind of nice, isn't it?
I wanted to really quickly riff on the concept of discipline. So this probably make me sound like a curmudgeon, but I do.
Back in my day.
Yeah, right.
Here it comes.
Can you do it in an old voice? That'd be great.
Maybe next time. I guess I do sort of the misery-driven development thing personally. So with code, what that means is, you copy and paste it 3 times, and then you figure out what the abstraction should be.
Right.
For infrastructure, for me, I need to see the mistake 3, maybe 2, 3 times before I can justify finding a technology that fixes that. So with Kubernetes, we're talking about a mistake like I deployed service A and it broke everything because I didn't know what was talking to service A, or it wasn't compliant, or whatever it might be. And that's where, you almost have to crash your app almost in order to, make that jump, because Kubernetes is such a big leap and a big commitment also.
Well, I think that should be quite good for people to hear that, because, in a way, people that just don't have a clue about this stuff, in a way, we're saying, don't worry about it yet. Focus on the bit you care about, the bit that's important and unique to what you're doing, and you will then be able to solve these problems later. But how easy is that? I mean, should we be building even our monoliths in a specific way with an eye to the future, or should we just build them however we have to build them to get it working?
99999. No, that's me trying to have a German accent like this. No, like
I thought you were
right?
doing an SLA.
No. I can see how that. Yeah. Here's the thing, right? So the earlier part of my career, right, as a software engineer, I used to I'd read the books, read the blogs, watch the videos, watch the conference talks. I'd basically be trying to become the perfect engineer who's building reusable software, reusable components, and trying to basically have, well orchestrated systems. All these things are still good, right? But over time, I've been around this industry long enough, going on 23 years now. I've been around this industry long enough. I've been around enough businesses long enough, built enough systems and applications over and over and over again to see that this dogma that we have around building, the perfect system, kind of like Clue and what's that Disney Tron movie, right? Basically solely concerned with building the perfect system, right? That you're failing to see what's around you, right? You're failing to see that, okay, well, this perfect application that you want to build right now, I have all these abstractions and these reusable components that you think you are going to reuse. Nobody's asking you for these reusable components yet, but you want to build them ahead of time, right? You want to create a future that you may have, right? And then you find out that, next month that the business is going a different direction on all the painstaking work you spent trying to build, these abstractions and layers upon things is now trash, right? Because you don't know what's going on above you, how many levels above you, right? Now, in a smaller company, in a startups or whatnot, that tends to happen a little less. You kind of have the information radiates to you. So you kind of get a sense of, okay, this is kind of generally what's happening. Or maybe we have one product, you have one line of business focus, and you know exactly what you're building. And so you can kind of a little bit, right, sort of a look ahead, right? But not too far ahead, because business is always changing. Business is what controls what your software is going to do tomorrow, not you. So trying to build abstractions early on in the process, like again, I take Aaron's approach. I need to see something showing up like 2, 3, 4, 5 times and become a pain to deal with before I create an abstraction around it, because I don't know what the business is going to want tomorrow. Right. So this whole notion, like we ingest all these notions, these best practices, as we like to call them in our space, right, around, how to build reusable software and all these things. Yes, but also add a layer of a realistic, right, sort of lenses to that, right? Look at your software as something that needs to evolve, because the business that it is serving also needs to evolve. Don't get way ahead of yourself. That's just recipe for disaster.
So that's very interesting. And I think even if the business doesn't change, still the best time to design solutions isn't at the very beginning, because we know the least about the problem then, don't we? Even if the business doesn't end up changing, still the learning that you get from building is so valuable. Ernest Hemingway said the only kind of writing is rewriting. And he was obviously talking about poetry, novels, books, but that applies to software too, doesn't it? When you rewrite things, you're doing it usually for a good reason and because you've learned something significant, which can only help.
What's up, Gophers? Do you have an app in production that's slower than you like? Of course you do. I know. But seriously, is the performance of your apps all over the place? Sometimes fast, sometimes slow? Do you even know why? Well, with Datadog, you will. You can troubleshoot your app's performance with end-to-end tracing and in one click, correlate those Go traces with related logs and metrics. You can also use Datadog's detailed flame graphs to identify bottlenecks and latency in your apps. Start tracking the performance of your apps today with a free trial at datadog.com/GoTime. And here's a bonus. If you sign up for a trial and install the agent, Datadog will send you a free t-shirt. That's a nice bonus. Once again, datadog.com/GoTime.
I will say that, like earlier we mentioned that, Matt, you run an app engine. And I think one of the reasons people levitate towards this, like, I need to do this all now, is that in their mind, they're like, if I don't do it now, it's going to be a lot of work later, and we're better to just put in the time now. And like you said, usually you don't know what you need to, you know, what your pain points are going to be and what's going to work for you. But what I like about like a Heroku or an app engine or any of those is that I think they get the major ones out of the way. Like they generally suggest like you're not running your database on the same server as your code. Your code usually doesn't have a file system that it can rely on being on the same, you know, on that physical hard drive. That could go away. They could talk to a different server. And if you get those major parts right, I feel like you're in a good position to start refactoring towards that. And that covers like your major bases. So like that, at least from my perspective, when Heroku and App Engine and those got big, that was probably my favorite part, was that it kind of got you the major ones, the major wins. And then later when you get to a really high scale, you'll know at that point what to focus on because it's going to be specific to your business.
Mm. Yeah, I mean, you're still designing APIs, aren't you? If you're building a monolith, you're still internally building APIs. You're going to have objects or structs or services or something. You're going to have functions with inputs and outputs and things. So you are already designing APIs. Of course, there's something nice about when you do have microservices, because you have to communicate in a more official way. Like you're not going to necessarily have compiler time help making sure that you're passing in the right types for arguments and things. So there's, it is a little bit different, but that kind of thinking can be quite useful, I think, even if you're building a monolith. And so, for example, in Pace, we have like different services inside, even though it is a monolith. We still break things up by group them up by functionality.
And that's the discipline that you want, right? Expecting a network boundary to help you create that discipline around your componentization sort of efforts is the wrong approach, right? Again, infrastructure, right, is not going to make your team more disciplined, right? You have to be disciplined within a monolith, right? And again, we seem to somehow think now associate monolithic applications, with bad. Monolith bad, microservice good. It's never that simple, right? So, and I've seen beautifully architected monoliths that do the job really well. They have clean boundaries and separations between different components within the monolith, right? When I see those, I smile inside because I'm like, okay, like somebody is being disciplined about how they build a software. Now, when you need to take something out of the monolith, right, to make it a standalone service, you already have a nice clean separation, right? You don't have that tight coupling in between all the other things within that monolith, right? You cannot easily sort of take it out. Now just have an interface, so some sort of RPC interface or HTTP interface, a REST API, whatever it is you want. This thing you've ripped out and that is now standalone, that can be scaled independently, right? So again, that's the ideal scenario for me, right? You have a well-architected monolith where the components are loosely coupled, that you can easily take something out, put it on its own server or its own container or its own wherever you need it to run, right? Serverless, whatever it may be. And then now you have the rest of the monolith now still able to communicate to that thing very cleanly. That's the perfect world in my view.
Yeah, I like that. Writing components that are easy to throw away is also turns out to be a bit of a superpower. You know, if you build a monolith and there's functionality that's just spread throughout the code base, then it's very difficult to unpick that. And so if it stops serving you in the way that you want it to, you know, you get stuck, really. You get stuck with it. And, you know, I've worked on projects where people will say, just don't touch that area. Just don't go near it because, you know, we're scared of it. Or the whoever built it, the wizard that originally built it, has now gone to work for Microsoft. I lost the metaphor there. But, you know, so people then become scared to touch things. And so, yeah, another thing that that's a handy thing to have is the ability to be able to rip those things out, like you say, and throw them away, and to do that without feeling like you're really losing too much, or it's such an expensive thing to do, or a risky thing to do.
Like, you describing that, to me, I've talked to a lot of different people about like ORMs and using them in your code. And I feel like a lot of the times when people have really big issues with them, a lot of the issues come down to the fact that they worked in a Rails code base where people basically accessed essentially the database anywhere in the code. And it led to these issues where you had like code that really should be like interacting with an interface of some sort to like get the data is instead like writing code that's actually executing SQL queries. And that, like you said, that makes it so that like refactoring the code or changing it as you need to or throwing something out is like next to impossible at that point, because you couldn't change your database implementation, at least not easily, without rewriting all of that code. But like Go, for instance, is one that I feel like interfaces in Go make it so much easier to separate these things without actually caring how you're communicating. Like, I don't care if this is a microservice or if it's, you know, if it's something that's running on the same server. I just need an interface here and I'm going to talk to it. And it's one of the things I've really liked about Go is that it just makes it so much easier to completely ignore that part of it and just write your code to be like, if you can give me these, you know, this little set of functionality, I can do my job.
I think once you get to that point where you really are in your Go code base, you really are taking advantage of well-defined interfaces and have multiple implementations of them, hopefully, you're in a good spot then to try to evaluate, hey, do I need to start splitting out microservices? But what I think a lot of people underestimate is how much technology you have to learn in order to split that stuff out. Just to get one process talking to another process on localhost over a network, that's hard enough. And this is all day zero, you know, before you actually see this thing running in production. You start just, you know, day zero, I've decided I'm going to build a third implementation of my interface that talks over the network to this thing that I've split out. Well, you have to figure out a couple things right then and there. Am I going to do HTTP? Am I going to do JSON? Am I going to do gRPC? Am I going to wade into that 3,000 project list of things in the CNCF site to figure out if there's something else?
I think I need Istio, right?
Yeah, you got to have Istio for that, right? But that's a good point because that talks about a little bit about compliance too. Am I in an organization that needs end-to-end SSL? Am I in an organization that needs to get a self-signed cert? The list really goes on and on. And like I said, that's day zero. When you push to production, you start feeling some pain about, oh, well, I can't debug as easily. I need a stack trace, 99.9% uptime, 99999, whatever it is. There's going to be a long, long road to get from it's a function call in memory to I have a thing reliably running over here on another server and I need my stuff to talk to that stuff. So you have a huge head start, like you said, John. You have a huge head start if you've broken this stuff out into really well-defined interfaces. And at that point, I really think, this comes down to good software design. And I really think once you have that, you have a pretty good leg up on getting it to where I can split out to a microservice. But you've got a lot of work ahead of you still. And I think a lot of people underestimate really how much work it is to get something production ready out, microservices based. And that's where we get caught up. That's where we end up writing more YAML than code. That's where we end up, not getting to market in 6 weeks or a year, whatever it is.
Because you're still building YAML.
Yeah,
Nothing takes you faster from being, a developer to all of a sudden being a distributed systems engineer faster than trying to adopt microservices and all these orchestration stuff. I mean, because now, like you said, Aaron, now you have to learn a whole bunch of stuff, like concern yourself with a whole bunch of stuff that really in the beginning you just wanted to, build this app, provide the business with a feature that they wanted. Now you're managing infrastructure and trying to learn YAML and Kubernetes and ECS, EKS, whatever these things are. I got chuckle, and it makes me sort of happy inside at the same time. And I think a part of me is like, okay, I don't want, and I, hopefully I can speak for you here, Aaron, as well. I don't think we want to be gatekeepers. I think we can sound like gatekeepers, right? As people who are in this space and are doing these things, I think we can sound like gatekeepers and basically trying to warn everybody away from these things. We're not. I'm certainly not, right? If you want to be a distributed systems engineer, if you want to be an operations engineer, whatever it is, if you want to deal with YAML all day, every day, please come into the field, right? We'll tell you that here's the resources to learn. Here are the things you need to know about. Heck, there's tons of conference talks. I mean, you know how to educate yourselves, right? You're in this space. Most of you are autodidacts, and you can sort of educate yourself. You will find the resources to learn and be that kind of engineer. But don't kid yourself, right? If what you want to do is remain a web developer and produce business value and build applications, whether they be monolith or serverless or whatever it is you want to do, there's a track for that, right? But the moment you cross into this whole orchestration, cloud native arena and concern yourself with these kinds of things, that's going to require you to basically expand, right, what you thought, right, you needed to know, right, to ship an application.
Do you think that's one of the things that causes confusion, is that people blend those tracks together as like one big web developer has to know how to do all of this stuff?
I blame the marketing. The marketing from these companies, that's exactly what they're trying to tell you.
Mm. And I think that's hard because I run into people all the time who basically in their mind, I have to learn Kubernetes and all these things. And I'm like, I've been working as a web developer for quite a while, and I don't know these things. So I can assure you, you do not need to learn them.
Yeah, but you've got it running on a Linux box in your corner, mate.
That's not my actual,
with no redundancy.
Stuff.
You've got a backup power supply, but you don't have redundancy in your server.
This isn't like my really insensitive stuff.
You put your app on a USB key and plug it on in.
I mail it to people and say, all right, now that you've purchased, here's the login.
Yeah. Remember when we used to ship the software via FTP? Those were the days, huh?
Yeah. I have shipped software by rsync more than once in the past 6 months.
Yeah,
a go it's easy with a go binary, right?
That's right. Just ship it over there. Yeah.
Oh, I've definitely done that.
Is rsync a band?
That's your
the follow-up band to NSYNC.
Yeah, it was the one after. They were just copying, basically. They're just copying NSYNC.
Oh, nice.
There we go. Back to Go then. This is Go time. So Go and the cloud, are they a match made in heaven? Why is Go, and by the way, for balance, I should say, because I don't want to exclude Satanists. So is it a match made in heaven / crafted by the Dark Lord in the depths of hell? Is it kind of special? Is Go
the PG rating?
Is there something special about Go for the cloud?
I wouldn't say special. I think Go is a very special language, don't get me wrong, but I think Go was in the right place at the right time. I really think so.
You don't think that, because it was designed, wasn't it, for modern ways of deploying things? Like it was certainly designed to make the use of multi-core processors, for example, where in previous languages that's quite a difficult thing to do. And so Go kind of was at least designed, because it's just because it is a bit more modern, it was designed with all this context.
Yes. Yeah, I should clarify. It's a great language for the cloud. I think it was at the right time, the right place at the right time for cloud native for this whole open source CNCF landscape. And it's because of what you just said. Because when you're a developer and you're looking to say build Kubernetes, go back to 2014 or whenever it was that the original folks were building Kubernetes. You've got to build a system that does need to take care of multi-core and does need to be really good at networking and databases and more. And your choices then are, let's see, C++, C, Java. I'm probably missing a bunch of those languages that give you good access to lower level primitives of the system. But when you're looking at Go, well, you do.
I see you skipping Node there. That was a slight. I saw it.
Throw Node in there. Throw everything, I guess. Throw everything in there. But what language can you pick up that doesn't need a VM, that has high level concurrency primitives built into the language, that can do networking in a couple lines of code, that's got really good support for built-in high level networking protocols? There's not a lot of other stuff out there. And if you're 3 engineers or however many engineers it was at Google and you're trying to build Kubernetes, or shout out to Nomad, because I saw some Nomad in the chat there. If you're HashiCorp and you're trying to build a distributed system abstraction layer, you kind of need those things, and you're going to get up and running with something like that faster with Go than probably with C++ or Java. Not sure about Node. Maybe Node will get you there just as fast. Although you don't have access to multi-core on Node, so there's a trade-off there as well. So I think Go really caught on because it has most of the stuff right out of the box that you need. And it was one of the only languages that had it at the time when a lot of these things were coming up.
Right place, right time. The language of the cloud.
I'd say it's probably not a coincidence that a company that probably has to deal with all these types of issues was also backing a language like that, like that it came from a company like that. Like I could imagine it would be hard for me at least to imagine Go coming from a 20-person startup that, just probably doesn't have the same problems.
Yeah, which is a good thing in a way, because it's born out of kind of these real environments. I think that's cool. Well, it's that time again, everybody. It's time for your unpopular opinion.
I actually think you should probably leave.
I already gave mine.
Yeah, you did. You broke the format, mate, essentially, and you will be
Sorry.
receiving a strongly worded letter from me.
Handwritten.
Yeah,
Handwritten? All right.
Yeah, sure.
We're updating the guest doc to say, save your unpopular opinions.
I can give a second if you all would like.
Yes.
I think I have plenty. I am a curmudgeon after all. So I can give plenty, yeah.
Do the voice.
Back in my day.
There we go. That's what I wanted. Okay, what's your second unpopular opinion, Aaron?
Well, I would say that Go is not the only language of the cloud or language of cloud native either. We've started to see some new applications, I guess, of languages in the cloud native space. I'll shout out to some of my old colleagues who I wrote that pass with. They're doing a lot with Rust for Kubernetes right now. And Linkerd is also written in Rust. That's a service mesh. Half of Linkerd is written in Rust. And Rust is turning out to be a pretty good language because of the safety aspect. It's got some really great performance characteristics, including with concurrency. And all that stuff is memory safe and concurrency safe when you compile it. So it's a little bit more difficult to learn. Some might say a lot more difficult to learn. It depends on who you ask. but you get some of those same properties of Go while also getting that safety guarantee. So you don't have race conditions, you don't have null pointer exceptions and that kind of thing. So definitely not at the scale of Go yet, but I have some confidence that it's going to get up there soon.
Is that also one of the benefits of microservices? Is like, as you mentioned, something's half written in Rust. Can you mix different technologies and kind of pick something that maybe is better suited for solving particular problems?
I think so, yeah.
Because that's harder to do in a monolith, isn't it?
Yeah. Of course, at the technological perspective, yeah, for sure, because you can have, Rust talking to Go over gRPC or whatever. But I think when we're talking about the layer cake that Johnny mentioned at the beginning, your app level code can be and probably should be something like Node or Python, because that's where you're writing business logic and you're talking to databases and rendering templates and all that. I would do it with Buffalo, for example, because that's my sort of most preferred web framework right now these days. But then when you're going lower down, well, you still might be writing Go. You might end up writing Rust because you got to integrate with some C stuff, and that's doable there. You might go and write some C if you've got to integrate with whatever's going on there. And this comes down to right tool for the job, but we're now applying it to the cloud native layer cake.
Right. Good one. Any other unpopular opinions?
I try to bring the curmudgeon to the show.
I say good one. What we're doing is taking the clips of all the unpopular opinions and then doing a poll on Twitter. So you can follow GoTime FM on Twitter and you can vote to decide whether that is indeed unpopular or not. So far, they've all been popular. And I don't know if it's just that the guests make such a compelling case and we're just suggestible. Or if, in fact, people are just not taking the segment seriously enough. Has anyone else got any unpopular opinions?
I do. But again, I have to, I guess, well, let me not poison the well here. I'm just going to say it. And if you think it's unpopular, that's your business. Right? Okay. I think every startup, at least, but even within the enterprise, right? There are, not just because you're in the enterprise and you have an orchestration layer doesn't mean everything needs to be microservices. But I think you should reason your way, right, out of a monolith before you adopt microservices, right? I mean, find all the reasons, right, why you don't need to deploy your application as a monolith, right, before you come up with the reasons, right, and the excuses and whatever it is you want to tell yourself, right, for adopting microservices and all the orchestration and baggage that comes along with it, right? Because if you cannot, right, realistically, right, and I don't mean just, sit down by yourself, write yourself a list and then kind of weigh pros and cons all by yourself, by your lonesome. No, get some feedback, have your entire team weigh in. Heck, create some language around it. Have your business leadership team weigh in on it if you can, right? I bet they'll ask you, hey, what's going to take longest to do? What's going to take longest to manage and maintain? What's going to cost more in terms of people and all that thing? All these things factor into that decision, right? So basically, you need to reason your way out of not choosing a monolith, right, before you adopt microservices. Because sometimes I think we try to look for reasons why we should use the tech we think is shiny and new and cool, right? And we shy away from the stuff that it might be old, but it works, right? The boring tech, right? There's a reason why SREs like boring tech, because excitement in infrastructure is never a fun thing, right? So yeah. That's my piece of advice, I guess.
Great.
So I did Y Combinator a while back.
Show off. What did you do? On-site Linux.
I think it was Paul Graham that had said, in his opinion, every startup should be using the language that whatever the founders are most comfortable writing with, that's the language they should be using. Because in most cases as a startup, you're going to be way quicker, even if that language is something that's going to be harder to hire for, or you don't think it's the best language for the job. Chances are you can build the thing faster if that's the language you're most efficient with.
Right.
I forget what the example was. There was one company that was written in not Haskell, maybe it was Erlang. There was some language that I would not have expected a modern startup to come with. And they did very well for the longest time. And that language did not hold them back.
COBOL?
Now, I don't know if it did later, and maybe they needed to change some stuff. I don't know. But I think, like to Johnny's point, I think at times people think, oh, I'm doing a startup. This is my opportunity to try these new things. And in reality, if you want this business, which is what it should be, to succeed, you need to focus on solving business problems, not like learning. And now, if you do want to build a project to learn, I think that's different, but I don't think that should be a startup necessarily. Maybe I'm wrong there, but...
No, it really makes sense. I think so. It's really about being pragmatic, isn't it? And resisting these shiny objects. But yeah, it is tough.
I should also add, if there are investors who want to pay me to go learn other languages, I'm all for investment. I will take it.
Yeah.
Drop them an email.
Great. Well, next week, we're actually going to be... This is a subject that comes up a lot. We're going to be talking about how you can introduce Go into your team. If and we talk about people chasing those shiny objects. Go for some people is a kind of shiny object, and we're going to be digging into that and exploring some ways that we could do that. So that'll be a very good one. Definitely tune in to that. And also, we don't do ads on Go Time, really. Like, we don't advertise Go Time. So tell your friends and that. Just tell them about it. I mean, obviously, if they don't have a computer, maybe just leave them alone. But if they're a developer or whatever, spread the word a bit for us, please, because we'd love to grow our audience a bit and meet new people.
Carlisi is joining us for any of our old listeners who've been around a long time. Not old as in old age.
Cool. Yes.
Anybody who's been around a long time, one of the original hosts, Carlisi, is going to be joining us next week.
Yeah, so that's going to be very exciting. And we are going to actually be doing something with Brian and Eric also coming up. They're part of the original cast.
OG.
Yeah. What does OG mean?
Well, you don't know what OG? Wow.
Original gopher.
Goodness.
Does it mean original gopher?
Well, we kind of co-opted it, but yeah.
Yeah, it doesn't make sense.
This is a safe version, yes.
Yeah, we're going to go with that for this.
Okay, now I don't know. I'm even more in the dark. Can someone on Twitter can someone just tell me what OG stands for, please?
We should. How about this? We'll stop recording, and then at that point we can discuss.
Organic grapes. We got someone organic grapes.
Organic grape.
Yeah.
Okay, yeah, that's good.
They Eric and Brian both grow grapes, so that's where the term comes from. Yeah.
I don't mind being treated like an idiot. No props. Well, unfortunately, it's been great hanging out, but that's all the time we've got today. Everyone who's listening, go away. See you next time.
Jeez. Wow.
All right.
Take care, everybody.
Stick around if you like, especially if you'd like to hear the guys singing Backstreet Boys. Well, for some definition of singing anyways. Did you know we'll be all over GopherCon this year? We have sessions over the lunch hour the last 3 days with a very special show on Friday. I have 2 words for you. Go Panic. Thanks to Aaron Schlesinger for joining us on the show, to Matt, Jon, and Johnny for hosting, to the mysterious Breakmaster Cylinder for these excellent beats, and to our longtime sponsors, Fastly, Linode, and Rollbar. That's our show for this week. Introducing your team to Go next week.
Okay, so we'll just do 1, 2, 3, and then clap after.
Yes.
Okay, here we go.
Who's counting?
We only get one of these. We've been told. Okay, 1, 2, 3. Brilliant.
Hey,
was
that was
close.
like the closest we've ever gotten.
Yeah, I think that was good.
Nice.
We're in sync.
We're in sync. In sync. Yeah, you know that's the name of
not
a band,
NSYNC.
right? Okay,
Not
not
NSYNC.
okay.
No.
Okay.
No, that's a different podcast where we invite guests on and we have to do 4-part harmonies.
Yeah. Okay.
I've apparently never been invited out.
Cheers, mate. Yeah, I didn't get in. Yeah.
You could start
Wait,
your
I think
own.
that was actually the wrong band. We're singing Backstreet Boys.
Oh, shows us.
That's probably why Matt didn't get in.
You're singing all the wrong band songs.
He's like, I'm a really big NSYNC fan, I swear. Start singing the wrong song.
That was a setup.
Yeah.
Oh man.
Oh, this is already going well, isn't it?
Oh yeah.
It's good.
Oh, it gets better.
It will.